Assalamualaikum and good day, dear student. Now we look at chapter 2, roots of equations. Open methods for secant methods. Secant methods. In many cases, the derivative of a function is very difficult to find or even is not differentiable. Okay, so that's why students, why we need secant methods, because sometimes if the function cannot be differentiated or difficult to differentiate, means that we need secant methods in order to replace Newton-Raphson methods. Alright. Alternative approach is by using secant methods. So the slope in Newton's Raphson method is substituted by backward finite divided difference. So this formula we call as backward finite divided difference formula. Right. So previously, we have xi plus 1 equal to xi minus fxi over f prime xi from Newton. So now, we replace this derivative with this formula. Okay, so we replace here. Alright. So if we replace this derivative from Newton-Raphson with this divided difference, then it will give you this secant method formula. Okay, this secant method formula. So look at your secant method formula. So in order to use secant method formula, you update your roots estimation xi plus 1 equal to xi minus this fraction here where you have fxi multiplied with xi minus 1 minus xi over f of your function at xi minus 1 minus f when x is equal to xi. So we look here. It looks like similar with force position methods, but there is a little bit different. Okay, because again, force position you must to choose the starting that bracket your roots. However, in secant methods, okay, you requires two initial guesses, but it's not necessarily bracket your roots. So this is the idea on how we improve the estimation by using secant methods. Okay, means that secant methods require two initial guesses. Alright, two initial, but not necessarily bracket the root. Okay, so you can see here the chosen of initial guess, not bracket your roots, because this is our aim, this is our true solution. Okay, and then after that, based on these two value, we get the value of fxi, okay, at your function here, and then the value of your fxi minus 1, and then again we find the tangent line, or we call as secant line, and then we extrapolate this secant line until this secant line touch your x-axis. Alright, then we will have the value for xi plus 1. So this secant line here, the formula for this secant lines is come from the backward formula. Okay, from this backward formula here. And then rearrange, you will get this secant method's formula. Okay, now we look at the algorithm on how to compute the roots of estimation by using secant methods. So for the continuous function, okay, fx equal to 0, step 1, choose initial values. We denote as x subscript -1 and x naught. And these two initial values not necessarily bracket your roots. And then we calculate fx -1 and fx naught. Step number 2, compute the next estimate. We denote as xi plus 1 by using secant method formula. Okay, so this is our secant method formula. Step 3, again, similar with other previous methods, we calculate the approximate percent relative error. Alright, current approximation minus previous divided by current multiplied with 100%. So similar with Newton's methods, at first iteration in secant method we can already calculate our approximate percent. Alright, and then step number 4, you compare the approximate percent relative error with the given stopping criterion in order to decide whether we need to continue or stop the computation process. If not satisfied, then you need to repeat step number 2 again.